In the grand and often violent story of our planet, there are moments that stand out, events so powerful they echo through history. The year was 1883. In the vast stretch of ocean between the islands of Java and Sumatra, a name was about to be etched into the memory of humankind: Krakatoa. This was not just another volcanic eruption, this was a cataclysm of almost unimaginable proportions, a force of nature unleashed with such fury that its effects were felt across the entire globe. On a late August day, this remote volcanic island exploded, creating the single loudest sound ever recorded in modern history. It was a roar that traveled thousands of miles, a definitive announcement that the Earth's ancient power was still very much alive and well. Before this fateful day, Krakatoa was simply a part of the landscape for the people living along the Sunda Strait. It was a tropical island, covered in lush vegetation, its volcanic nature dormant for what seemed like an eternity. Few who sailed past its shores could have guessed the immense pressure building deep beneath its serene surface. The eruption that followed would not only obliterate the island itself, but would also send shockwaves, both literal and figurative, to every corner of the world. It became a benchmark for volcanic disasters, a story told and retold to illustrate the sheer, untamable power that sleeps just beneath our feet, reminding us of our small place in the grand cosmic and geological dance. The significance of the 1883 eruption extends far beyond its immediate devastating impact on the region. It was one of the first global disasters to be documented in near real time, thanks to the recent invention of the telegraph. News of the explosions, the colossal tsunamis, and the darkness that fell over the land spread with unprecedented speed. Scientists and ordinary people alike were captivated and horrified by the reports. The event marked a turning point in our understanding of volcanology, atmospheric science, and the interconnectedness of our world systems. It showed, with terrifying clarity, that an event in one remote corner of the planet could paint the skies of London and New York with otherworldly colors. As we look back on this monumental event from our vantage point today, on December 27, 2025, the story of Krakatoa serves as a powerful and humbling lesson. It is a tale of destruction, but also one of scientific discovery and human resilience. It reminds us that the Earth is a dynamic and ever-changing entity, its surface constantly being reshaped by the fiery forces within. The eruption was a tragedy of immense scale, but in its wake, it provided a wealth of knowledge that helps us better understand and prepare for the natural forces that shape our world. The story of Krakatoa is not just about an explosion, it is about the day our planet truly flexed its muscles and made the whole world listen. To understand the fury of Krakatoa, we must first look at where it was born. The volcano was located in Indonesia, a sprawling archipelago of over 17,000 islands. This nation is a place of incredible beauty, but it is also one of the most geologically active regions on the entire planet. Indonesia sits directly on what scientists call the Pacific Ring of Fire, a massive horseshoe-shaped zone that stretches around the Pacific Ocean. This ring is where many of the Earth's tectonic plates grind against each other. It is a place of constant movement, a hotbed of earthquakes and volcanic activity, giving birth to mountains and fueling the fires deep within the Earth's crust. The specific location of Krakatoa in the Sunda Strait is no accident. It lies precisely at the convergence point of two of these enormous tectonic plates, the Indo-Australian Plate and the Eurasian Plate. For millions of years, the heavier Indo-Australian Plate has been sliding beneath the Eurasian Plate in a process known as subduction. As it dives deeper into the Earth's mantle, the incredible heat and pressure cause rock to melt, forming vast chambers of magma. This molten rock is less dense than the surrounding material, and it relentlessly seeks a path to the surface. Indonesia, with its more than 130 active volcanoes, is dotted with the results of this epic geological struggle. Volcanoes, like Krakatoa, are known as stratovolcanoes. These are the classic, cone-shaped mountains we often picture, built up over thousands of years by layer upon layer of hardened lava, ash, and rock from past eruptions. Before 1883, the island of Krakatoa was actually a single landmass composed of three distinct volcanic cones, a testament to its long history of activity. List. Media group. Old photograph or illustration of Krakatoa, with three cones. Aerial view showing volcanic cones, labeled map of Krakatoa's cones. Stocka would distribute equally three distinct volcanic cones. This structure, however, concealed a volatile heart. The magma chamber simmering beneath was not just any molten rock, it was rich in gas and silica, a combination that creates incredibly thick, sticky magma. List: Media Group, thick, viscous lava flow, close-up of lava with gas bubbles. Gas-rich magma, emerging from Ventia Stocka distribute equally, rich in gas and silica. This viscosity prevents gas from escaping easily, allowing immense pressure to build up over time, like a shaken bottle of soda waiting to be opened. This geological setting is the key to why Indonesia is home to so many powerful and explosive volcanoes. The process of subduction continuously supplies fresh fuel to the fire, creating a seemingly endless cycle of volcanic construction and destruction. The very soil that makes islands like Java and Sumatra so fertile and able to support millions of people is a direct gift from these volcanoes, but this gift comes with a constant underlying risk. The people of Indonesia have learned to live with this duality, in a land of both incredible abundance and profound danger, a land literally forged in the planet's internal fire, where the ground beneath their feet is never truly still. For 2 centuries, the great mountain of Krakatoa had slept. The last significant eruption was believed to have occurred in 1680, and since then, the volcano had settled into a long period of dormancy. Local populations saw it as just another island, its slopes covered in dense tropical forest. But deep underground, the geological engine was never truly off. In the years leading up to 1883, subtle but significant changes were taking place. The slow, inexorable movement of the tectonic plates was forcing more and more magma into the chamber beneath the island. The pressure was building, and the sleeping giant was beginning to stir, sending out faint whispers of the chaos to come. The first clear signs that something was wrong appeared in May of 1883, about 3 months before the main event. The captain of a German warship, the Elizabeth, reported seeing a towering column of ash and steam rising from one of Krakatoa's cones. The plume was estimated to be nearly 7 miles high, a dramatic announcement that the volcano was active once again. Soon after, the sounds of explosions could be heard in Batavia, which is modern-day Jakarta, over 100 miles away. Ash began to fall on nearby islands, and a light blanket of pumice, a type of volcanic rock so light it can float, covered the surrounding sea, creating a strange, gray carpet on the water's surface. Despite these dramatic displays, life in the region continued with a sense of cautious curiosity rather than alarm. The initial eruptions were intermittent and seemed to pose no immediate threat to the populated coastlines of Java and Sumatra. In fact, the spectacle attracted tourists. Groups of sightseers would charter boats to get a closer look at the smoking mountain, marveling at the fireworks of nature. They sailed through floating fields of pumice and watched as the volcano vented its steam and ash into the sky. Few could comprehend that these were not the main performance, but merely the opening act for a catastrophe of a scale that no living person had ever witnessed before. As the summer progressed, the activity did not cease. Earthquakes, once rare, became more frequent and were felt as far away as Australia. The rumbling from the volcano was a near-constant companion for those living along the Sunda Strait. The air often carried the sharp, acrid smell of sulfur. The preliminary eruptions had cleared a path from the magma chamber to the surface, and now, a much larger volume of superheated gas-rich magma was ascending. The mountain was groaning under the immense strain, its structure weakening with each passing day. The stage was being set for a final, catastrophic failure. The world was unknowingly on the brink of disaster. The prelude to disaster ended on the afternoon of August 26, 1883. The eruption suddenly intensified with terrifying force. A colossal black cloud of ash, rock, and gas blasted 17 miles into the sky, plunging the entire region into an unnatural pitch-black darkness. The noise was deafening, a continuous thundering roar that shattered windows and terrified residents. Minor tsunamis, generated by the violent explosions and the collapse of parts of the volcano into the sea, began to strike the nearby coastlines, serving as a grim warning of what was to follow. For the people huddled in the darkness, it must have felt like the end of the world had arrived. But the worst was yet to come. The climax arrived the next morning, on Monday, August 27th. In a series of 4 titanic explosions, Krakatoa tore itself apart. The first blast occurred at 5:30 a.m., followed by another at 6:44 a.m. But it was the third explosion, at 10:02 a.m., that entered the annals of history. This was the cataclysmic detonation, an event so powerful it is widely considered to be the loudest sound ever produced on the planet in recorded history. It was a sound that transcended hearing. It was a physical force, a pressure wave of immense power that radiated outwards from the Sunda Strait, traveling literally around the world multiple times. The sound of this third explosion was beyond comprehension. It was clearly heard over 3,000 miles away on the island of Rodriguez in the Indian Ocean, where locals thought they were hearing the cannon fire of a distant ship. It was heard in Perth, Australia, nearly 2,000 miles away. In total, the sound was audible over an area covering more than 10% of the Earth's surface. For those closer to the eruption, the effect was devastating. Sailors on ships, within a 40-mile radius, had their eardrums ruptured by the sheer force of the sound wave. Barographs, instruments that measure atmospheric pressure, as far away as London and Washington, D.C., registered the spike as the shockwave passed over them hours later. The final major explosion at 10:41 a.m. completed the island's destruction. When the smoke and ash finally began to clear days later, it was revealed that 2/3 of the island of Krakatoa had simply vanished. In its place was a massive underwater crater, or caldera, over 200 meters deep. The volcano had effectively disintegrated in one of the most violent geological acts ever witnessed by modern humanity. The energy released was estimated to be equivalent to 200 megatons of TNT, about 13,000 times the power of the atomic bomb that devastated Hiroshima. The day of the Great Roar was over, but its terrible consequences were only just beginning to unfold. With the island of Krakatoa blown to pieces, the eruption unleashed its most deadly weapons: pyroclastic flows and tsunamis. The immense column of ash and rock, which had reached up to 50 miles into the atmosphere, could no longer support its own weight. It collapsed back down upon itself, creating superheated avalanches of gas, ash and pumice known as pyroclastic flows. These fiery clouds, with temperatures exceeding 1,000 degrees Celsius, raced across the surface of the sea at speeds of over 100 miles per hour. They were so hot and moved so fast that they traveled on a cushion of steam, literally boiling the water beneath them as they went. These incandescent flows were unstoppable. They traveled an astonishing 25 miles across the Sunda Strait to reach the shores of Sumatra. The village of Ketimbang and its surrounding areas were directly in the path of this inferno. There was no escape. The pyroclastic flow incinerated everything it touched, instantly killing thousands of people. The nearby island of Sabisi, which was home to around 3,000 people, was completely sterilized by the heat and suffocating ash. The pyroclastic flows represented the direct, fiery wrath of the volcano, a force against which there was absolutely no defense. They were a swift and terrible agent of death for those closest to the eruption's epicenter. However, the greatest loss of life came from the water. As the volcano collapsed into the sea and the massive pyroclastic flows displaced enormous volumes of water, a series of catastrophic tsunamis was generated. These were not ordinary waves, they were mountains of water, some estimated to have reached heights of over 120 feet, as tall as a 12-story building. They radiated outwards from the smoldering remains of Krakatoa and slammed into the coastlines of Java and Sumatra with unimaginable force. Entire towns and villages that had lined the shores of the strait for generations were simply wiped off the map, swept away in a matter of minutes. The official death toll compiled by the Dutch colonial authorities at the time was 36,417. It is a staggering number, but many historians believe the true figure could be much higher, perhaps closer to 120,000, as many remote villages were never officially accounted for. Of these deaths, it is estimated that around 90% were caused by the tsunamis. The waves were so powerful they carried a steamship, the Barao, nearly 2 miles inland, depositing it in a forest. Coral blocks weighing hundreds of tons were ripped from the seabed and thrown ashore. For the people of the Sunda Strait, the aftermath of Krakatoa was an apocalyptic landscape of death and destruction on a scale that really, honestly, just defies imagination. The colossal power of Krakatoa was not confined to the Sunda Strait. The eruption was so massive that it injected enormous quantities of material high into the Earth's stratosphere, the upper layer of our atmosphere. An estimated 25 cubic kilometers of rock, ash, and dust were blasted into the sky. But most importantly, the eruption also released vast amounts of sulfur dioxide gas. Once in the stratosphere, this gas reacted with water vapor to form tiny droplets of sulfuric acid, creating a fine aerosol veil that gradually spread around the entire planet. This veil acted like a planetary sunshade, fundamentally altering the Earth's climate and appearance for years to come. One of the most immediate and visually stunning effects was the change in our skies. The fine particles suspended in the stratosphere scattered the sunlight in a peculiar way. While they reflected some sunlight back into space, they were particularly effective at scattering the shorter wavelengths of light, like blue and green. This allowed the longer wavelengths, the reds and oranges, to dominate the view, especially during sunrise and sunset. For the next 3 years, people all over the world were treated to sunsets of spectacular and often alarming intensity. The skies would ignite in fiery shades of red, purple, and orange, lingering long after the sun had dipped below the horizon. These breathtaking sunsets were recorded globally, from Europe to North America. Artists of the era were inspired by the vivid, otherworldly colors. It is even theorized by some art historians that the blood-red sky depicted in Edvard Munch's famous painting The Scream was inspired by the lingering atmospheric effects of Krakatoa, which he would have witnessed in Norway. Beyond the visual spectacle, the aerosol cloud had a more tangible effect on the global climate. By reflecting a portion of the sun's energy back into space, the sulfuric acid veil caused a noticeable drop in global temperatures. On average, the Earth's temperature fell by approximately 0.4 degrees Celsius in the year following the eruption. This cooling effect disrupted weather patterns around the world, leading to unseasonably cold summers and altered rainfall. While not as dramatic as the year without a summer that followed the Tambora eruption decades earlier, the impact was still significant. The atmospheric dust also created other strange phenomena, such as the appearance of a bishop's ring, a faint halo around the sun, and noctilucent clouds, which are wispy, electric blue clouds that form at very high altitudes. The eruption of Krakatoa was a powerful demonstration of how interconnected our planet's systems are, proving that a single geological event could reach out from a remote island and touch the daily lives of people on the opposite side of the world. To truly grasp the magnitude of the 1883 Krakatoa eruption, it helps to place it in context with other volcanic events in history. Scientists use a scale called the Volcanic Explosivity Index, or VEI, to measure the power of eruptions. It is a logarithmic scale, meaning each whole number represents an eruption 10 times more powerful than the one before it. The 1980 eruption of Mount St. Helens in the United States, a major event that captured the world's attention, was rated as a VEI 5. The infamous eruption of Mount Vesuvius in 79 AD, which buried the Roman city of Pompeii, was also a VEI 5. Krakatoa, however, was a full order of magnitude larger. The 1883 eruption of Krakatoa registered as a VEI 6, earning it the classification of colossal. It was significantly more powerful than Mount St. Helens, Mount Vesuvius, or the 1991 eruption of Mount Pinatubo in the Philippines, which was also a VEI 6 but slightly smaller in scale. The energy released by Krakatoa was immense, but it is humbling to realize that it was not the largest eruption in recorded history. That distinction belongs to the 1815 eruption of Mount Tambora, another Indonesian volcano. Tambora was a VEI 7 event, roughly 10 times more powerful than Krakatoa, and it ejected far more material into the atmosphere. The Tambora eruption had even more catastrophic global consequences. It led to what became known as the Year Without a Summer in 1816. The massive amount of ash and sulfur it spewed into the stratosphere caused global temperatures to plummet by as much as 3 degrees Celsius. This led to widespread crop failures, famine, and disease across the northern hemisphere. While Krakatoa's impact was global, Tambora's was a global catastrophe, directly causing the deaths of an estimated 70,000 to 100,000 people from its immediate effects and the subsequent starvation. It stands as the most powerful and deadliest volcanic eruption in all of recorded human history. Going back even further into prehistoric times, we find evidence of eruptions that dwarf even Tambora. About 74,000 years ago, the Toba supervolcano, also in Indonesia, exploded in a VEI-8 mega-colossal event. This eruption was thousands of times more powerful than Krakatoa and is thought to have triggered a volcanic winter that lasted for years. Some scientists have hypothesized that this event created a bottleneck in human evolution, drastically reducing the global human population. In this context, Krakatoa, as monstrous as it was, serves as a reminder that our planet is capable of even greater violence. It was a giant, but there have been titans. After the colossal explosion of 1883, the island of Krakatoa was gone. In its place, the deep dark waters of the Sunda Strait filled a massive underwater caldera. For decades, the site of one of the world's greatest natural disasters remained quiet, a submerged grave marker for a vanquished mountain. But the geological forces that created Krakatoa had not disappeared. The subduction of the Indo-Australian plate continued its relentless push, and deep beneath the sea floor, magma began to accumulate once more. The cycle of destruction was slowly giving way to a new cycle of creation. The volcano was not dead. It was merely dormant and preparing for a rebirth. In 1927, about 44 years after the Great Eruption, sailors and fishermen in the area began to notice something strange. Steam and ash started bubbling up from the center of the submerged caldera. The volcano was stirring again. Soon, a new cone of volcanic material breached the surface of the water, forming a small black island of ash and rock. It was a fragile creation, quickly eroded by the relentless waves of the strait. But the eruptions continued, and the island kept rebuilding itself. The local people gave it a fitting name, Anak Krakatoa, which translates to the Child of Krakatoa. It was a direct descendant of the mountain that had so violently disappeared. Over the decades, Anak Krakatoa grew steadily. Fueled by frequent but smaller-scale eruptions, the new volcanic cone rose from the sea, becoming a permanent feature of the landscape. It grew taller and wider, layer by layer, in a perfect demonstration of how stratovolcanoes are built. By 2018, it had reached a height of over 338 meters above sea level. It became a popular destination for volcanologists and adventurous tourists, a living laboratory for studying island formation. But the child carried the same volatile DNA as its parent. The potential for violent and unpredictable behavior was always present, lurking just beneath its growing slopes. That potential was tragically realized in December 2018. A section of Anak Krakatoa's cone, which had been built on a steep, unstable slope of old landslide debris, collapsed into the sea. This underwater landslide triggered a sudden and deadly tsunami with little to no warning. The waves struck the nearby coasts of Java and Sumatra, killing over 430 people and injuring thousands more. The event was a shocking reminder that even a smaller version of Krakatoa could be incredibly dangerous. The collapse sheared off much of the volcano's height, but Anak Krakatoa continues to erupt, rebuild, and evolve, carrying on the fiery legacy of its infamous parent in a perpetual cycle of destruction and rebirth. It is easy to view volcanoes solely through the lens of destruction. The story of Krakatoa, with its deafening explosions, terrifying tsunamis, and tragic loss of life, certainly reinforces this perspective. The immense power unleashed by these geological behemoths can wipe out cities, alter climates, and bring human activity to a standstill. They represent one of nature's most formidable and unpredictable forces, a raw display of the planet's inner turmoil that commands both fear and respect. The scars, left by eruptions like Krakatoa, Tambora, and Vesuvius, are etched deeply into our history, serving as permanent reminders of our vulnerability in the face of such overwhelming power. However, to focus only on the devastation is to see only one side of the story. Throughout human history, people have been drawn to live in the shadow of volcanoes, and for a very good reason. The same process that brings destruction also brings life. The ash and rock that volcanoes eject during an eruption are incredibly rich in minerals and nutrients. Over time, as this material breaks down, it creates some of the most fertile soil on Earth. This volcanic soil is a gift to agriculture, allowing farmers to produce abundant harvests year after year, supporting dense populations and flourishing civilizations. This duality is perfectly illustrated on the island of Java, which lies just across the Sunda Strait from where Krakatoa once stood. Java is one of the most volcanically active places in the world, yet it is also one of the most densely populated islands on the planet, home to over 147 million people. This is no coincidence. For centuries, the repeated eruptions of Java's many volcanoes have blanketed the land in nutrient-rich ash. This has created incredibly productive agricultural lands that can sustain a massive population. The very volcanoes that pose a constant threat are also the source of the island's immense agricultural wealth and vitality. In the end, volcanoes are an essential part of our living planet's machinery. They are a fundamental force of creation as much as they are of destruction. They build new land, replenish the soil, and even vent gases that help regulate our planet's atmosphere over geological timescales. The story of Krakatoa is a dramatic chapter in this ongoing saga. It teaches us about the awesome power of the Earth, but it also fits into a larger narrative of planetary renewal. By studying these fiery mountains, we not only learn how to better protect ourselves from their wrath, but also gain a deeper appreciation for the complex and dynamic processes that have made our world the fertile and habitable place it is today.